Welcome to Homework Lib.
Okay, so we're doing chapter 29, problem 63. So in this problem, we have some points here separated by distance r. So here's a point A, C, and B. We have C is at the origin here, and A is along the y-axis, and B is along the x-axis. Okay, so this is all in a circle of magnetic field of radius big R. So this whole thing in the xy plane has a magnetic field pointing into the page. Okay. So it also tells us that the time derivative of the magnetic field is greater than 0, which means we're increasing, which means we also have an increasing flux with respect to time. Okay. So using Gauss's law, we know that the surface line integral E dot dl is going to be the negative change in flux with respect to time. So from that, we now know that E times the circumference in a Gaussian surface equals A times B. A times dB dt. And the area of that Gaussian shell is pi r squared because it's a circle at that radius. So we now are left with E times 2 pi r equals pi r squared dB dt. We rearrange that, we can find out the magnitude of our electric field as 1 over 1/2 r dB dt. Cool. So the only reason we were able to do this is because we know that the electric field is exactly always tangential to our Gaussian surface. So what that is saying is if this is our origin, here's our Gaussian surface at radius r, the electric field is always tangential here. And it's constant, so that at every point along this circle it has the same magnitude. It's only dependent on the only dependence on the radius. So this is all within our big radius here. Okay, so what that tells us now is if we're wanting to know the force at different points, this is given as Q times the electric field. So the force is going to be the same direction as the electric field. That's the key here. So for part A, we're looking at point A and seeing what is the force. So at point A is exactly in the y direction from the origin, which means straight up. And you can see here that the E field is pointing to the left. So the magnitude of F is given as QR over 2 times dB dt. And the direction is to the left, negative x direction. Cool. So now let's go to part B. We're just asking for the force again. So for point B, we're in the positive x direction from the origin. So if we look back at our diagram here, the tangential E field is pointing straight up in the y direction. Now the magnitude, however, since it's also only r away, is going to be exactly the same. So it's going to be the same magnitude pointing upwards to the positive y direction. Cool. So now for point C, we're at the origin. That means r equal to 0, right? So if r is equal to 0, there is no E field, and there's no force. So C is not feeling anything in this magnetic field.